Hello and welcome to FasTALKS. My name is Mikko Tuomala. I'm the marketing director of Fastems and the host of this show. Today in the studios we have Teemu-Pekka Ahonen from our product management team and then one of our solution architects, Seppo Pyykkö. Would you guys briefly introduce yourselves so the listeners know who are today here with me? Teemu might go first.
Okay, so my name is Teemu-Pekka Ahonen and I'm working at Fastems as a product manager. Fastems history for the past 14 years, started from summer trainee and moved progressively to product management duties. I've been working with industrial robots practically my whole career.
Yeah. Besides the automation profession, what are the things that you get interested in or do at your spare time?
Well, the latest thing for me has been really to go deep dive back into RC cars, so remote controlled cars with my 3.5-year-old son.
Yeah,
so I don't know whether the toys are for me or for the son. So maybe for me.
Maybe both, yeah. Okay, then Seppo.
So my name is Seppo Pyykkö. I work here at Fastems nowadays as a solution architect. I have also roughly 15 years of Fastems career behind me. Started as a mechanical design engineer and made my way up to software-related matters. Right. I mainly work with our frontline salesmen and with our sales back office and support them in technical matters related to control software.
Yeah. And besides your automation profession, what kind of drives you?
I have 50-year-old house, so I have constantly something to do when I'm home.
So no spare time problems then?
Nothing at all.
Yeah, all right. So today's topic for our episode is tool management. What is it? Why is it relevant? And how to implement proper tool management. So let's begin point blank by asking the question, well, what is tool management? What is it that we're talking here? Which one of you guys want to go first and do the definitions? First
of all, it's really a wide topic because tools are such that they are factory-wide things. So there are quite many matters that are related with the tool management thing.
Yes.
And I think that in this context today we're going to talk about physical tools and managing the tool data. But we won't be going into the bill of materials of the tool, so practically telling how the tool is built, so which parts are in the tools. That's normally the domain of the TDM systems.
Yes.
So we're talking about these tool entities and maybe the tool geometric data of the tools.
Yes, in this context. How to manage the data around there. So why then is tool management relevant? Why is it an important practice and what can be gained with that?
Well, first of all, tools are an important factor in the product quality itself. As the tool is the one that actually takes the chip out of metal and touches the part when it's being manufactured. Yes. So the tool data and the tool quality has a huge impact on the product quality itself.
Yes.
Yeah. This is also a very, like Seppo already said, that this is a very multi-phased topic, and I think that there's a lot of efficiency related matters related also to the tools that we need to know also that, for example, that where are the tools, what are the tools, and how to describe these tool individuals, and so there's a lot of factors contributing to the tool before we can actually even start to use it. So
yeah. So the efficiency is a big word, and it has to do with production planning, right, Seppo?
Well, in a way, yes. So the first thing in efficiency is that you need to have the tools in the machine in order to produce something.
Yeah, naturally.
So if you don't have the tools, the machine will not run.
Sure.
And that's the first big lack of efficiency in a machine shop, that the machines stop because of a lacking tool in the magazine.
Yeah. So you have to know what tools are necessary and when.
In order to play that game, it helps to know in advance which tools are needed and bring those needed tools in the magazine already before the machine actually would require that tool.
Yeah, and that when and if that doesn't happen, it's that causes inefficiencies, right?
Of course, because if the tool is not there, the machine will stop, red light is blinking, and the machine waits for the operator to bring the required tool.
Sure, so quite straightforward, I would say.
And then we come to the kind of the big challenge that, okay, if we didn't prepare for this, that's always a surprise element that, now the tool is out, so who's going to do what? Do we even have the bits and pieces to make a new one? And so how to prepare for the consumption of these tools in an efficient way.
Yeah. Then there's the whole discussion and practice around the offsets and handling those. How is that relevant here?
Well, if you need to make accurate parts, so the accuracy is below, let's say, 0.3 millimeters or some tenth of millimeters, you need to somehow compensate the tool wear or the inaccuracies that may happen when the tool is set up.
Exactly.
And let's say the most traditional way to do is that you first machine and then you measure and then you correct according to your measurement. And these corrections can be either written into the NC program code itself, or what would be the better way to use the correct place in the machine tool control where the corrections are written.
Yeah.
And if you want to make this more efficient, the way how you do it is that you actually measure the tools beforehand, before you put the tools in the machine.
Yes.
And then simply feed in the corrections into the machine control as the tools are brought in.
Yeah. What was the problem with the, dealing with this offset with the the NC programs? You mentioned it's better to use the presetter. Why that is the case?
Well, first of all, it's quite inefficient when you need to first run a batch of production or make one piece and measure, and then type in the corrections as you need to stop the production while you are doing it. So that's the first thing of inefficiency there.
Yeah. Quite self-evident. What it causes that if there's no proper tool management, it might be that the tool lifetime is not known. How is that a problem?
Well, it's a big challenge in that case, that when you think about, okay, I want to manufacture these parts that I have an order for example. So it's kind of a shot in the dark if you don't know how much you have. So you start in the tool.
Yeah.
So how much tool lifetime you have. So then you go into manufacturing the start the batch, and then somewhere maybe you've done maybe 40% of the batch, and then you get a red blinking light that, hey, I'm out of tool life. So then again, you get a disruption to the production of the batch.
And the other important factor is then the quality, because as the tool wears, the surface quality gets worse.
Yes.
And you might run up being out of tolerance box with the dimensions. Yeah. And that's even worse because that's something that you don't necessarily notice if you are not checking or measuring each part. Okay. So there's a big risk that you actually produce scrap parts without noticing it when the tool life is not under your control.
And so it's not only about the delivery performance, but also the quality.
Exactly.
Yes. How about some special situation and tool management in those? I've understood that product variance has something to do with materials, and if you have very expensive tools at your shop, this might have something to do with the relevance of tool management. How would you guys elaborate that?
Well, I think this is a very interesting topic, because it's not just the kind of the data level of the management. It is also about how do you supply tools to different kind of machinery, and I think this is where we get down to the automation solutions in this tool management context.
Come back to that later.
Yeah, but kind of that. I think that if you're really thinking about flexible manufacturing, one of the basic cornerstones is that, for example, in an FMS system, any work can be made on any machine. That's a very powerful assumption, or a kind
for rerouting.
So at any given time, you can put any work into any machine, and that basically means that all of the machines have to be equipped to manufacture all of the parts in the system at any given time, and this is a tool challenge.
Yes,
especially if you have expensive special tools. Then you have to equip all of the machine tool magazines with the same high-end special tool, which might end up being costly.
Yeah, unless you have another solution for them.
Yes.
Yeah. How about with the special materials?
Well, using special materials leads to high tool consumption, which means that you should be able to equip your machines with a large number of sister tools, because the lifetime of one individual tool might be quite short. We can be speaking about minutes there. Yeah. So in order to make, for example, an unmanned series or unmanned production overnight, would mean that you would need to have hundreds of tools in your magazine, which practically is impossible.
Yeah, for sure. Okay, quite many reasons. How would you guys summarize this? So if someone just asks you point blank, why tool management is relevant, what would be the kind of summary of this all?
I think it's a very important topic also from the process aspect and the quality point of view, like already discussed. That I think it's really one of the fundamental machining elements of the machining that in the end is giving the right quality and forms the basis for automation, how to make the tools last in a predictable manner. And so there's that. It's really in the core of machining as well. As like
yeah. Seppo, anything to add?
Well, as Teemu-Pekka said, it's the first source of quality.
Yes.
And then also the tool management gives some freedom for your production planning. So if you are able to manage your tools in a way that you don't have to carefully plan in which machine you manufacture which part, that gives you quite a bit of freedom in your production planning. So you can freely choose the machines that makes the parts, which in turn means that you can increase the utilization rates of the machines.
Yes,
you can
naturally.
just simply queue work to all of your machines, as you can consider them being parallel with each other.
Yeah, and even if something should happen, like an accident, you can reroute.
Exactly.
Yes. So many good reasons and motives for doing good tool management and getting the most out of that domain in your manufacturing. What would be your guys' suggestions on how to do tool management in practice? What are some steps that one could really take and start to tackle the problems and get some benefits?
I think that at the, let's say, the very basic level is that there is some kind of systematic way to handle this. That you have a...
You mean a software?
No, I think it goes also deeper into that the handling of the individual tool bits and so that you have a system in place how you want to develop your tooling.
Yes.
I think that's really the basis. And on top of which you can then start to implement the softwares and hardwares and what comes later. But if you don't have the kind of the basics in place, it's difficult to build also the top of the pyramid then.
Yes,
for sure. What do you think, Seppo?
Well, it of course depends on the level in which you are currently. So if you are still running a test chip and measuring and correcting your NC programs, I think the first step would be starting to preset your tools outside of the machine.
Yeah, what does that require?
Well, then that would require a presetting device from some of the suppliers. But when you have reached that level, then you might consider, for example, having a planning software that can calculate the estimated tool need already beforehand.
Yes.
So you can kind of divide the rhythm of the tool management from the rhythm of the manufacturing, and instead of being reactive, start actively producing the tools before they are actually required.
Yeah. And that software would talk to what other systems or devices with preset perhaps?
Well, the software is related maybe to presetters, but mostly this is then advanced planning software.
Yes.
And with or without automation hardware.
Yes. Can go both ways.
Exactly.
How about taking it even further to actually automating the tools? What kind of options or ways forwards there can be?
Well, we propose centralized tool automation or centralized tool systems where the machine tools which are connected to some sort of an automation, like a pallet FMS, are connected with each other also from the tool magazines. So all tooling in all connected machines are actually in one large tool magazine.
Yeah.
And additionally, you have auxiliary storage capacity. Yeah. So this means that instead of having a tool magazine of 40 tools or 80 tools or 240 tools, you basically have a tool magazine of 2,000 tools or 3,000 tools.
Yeah.
That you can use.
Yes. And how do you handle that from the software perspective? That sounds like quite a lot of bits and pieces to make work together.
Well, there's some work on the basic data side. This control software must know which tools are required for which part. This information usually is automatically extracted from the NC program. And the software needs to plan the work in advance. But after that, the miracle happens automatically, so there's not much of an extra work for the operators.
Yes.
The system knows which is currently made where and is capable of delivering the right tools into the right machine just on time before they are required.
And the system also knows about the wears of those tools.
Yes.
The lifetime. Yeah.
The lifetime, and it might know the geometrical data of the tools. There are other ways for handling the geometrical data as well as using RFID chips. Yeah. There you can go in many ways depending on the overall situation at your factory.
And this also helps or using a centralized tool storage helps you reduce the amount of unnecessary tool transfers manually. Or manual tool transfers. So you don't have people taking tools from the machines to the presetting room and back on 20 machine tools. You might have only one access point to the centralized magazine that might even be right next to the tool room. So you have only one place to input and output used and new tools into the system. And that is a big benefit as well from the elimination of unnecessary movement.
Yeah. So sounds like it all boils down to the efficiency that we began the discussion with, and being able to manage tools as resources in the production, and having control over things and not getting surprises of broken or missing tools or wearing out in the middle of the program. How would a company could then get started with pedal tool management? I think we already somehow discussed that, but let's break it down into really practical things. That how could a machining shop take the first steps in getting pedal tool management in order or to a better shape?
Well, one of the first steps could be kind of to first think about, okay, how could I make this, improve this? Thinking about the tapers that you're using, different kind of tool shanks. Is there room for standardization in there that helps as well? Yeah. And then maybe, like Seppo already said, that think about this presetting, using of a presetter, which contributes heavily to elimination of manual errors in the tool data. So if you're really trying to make a very accurate production down to the thousandths of a millimeter, it has a big effect where the comma is in the value. So
yes.
And then also the damages could be kind of really heavy. So what kind of damages are we talking about with the comma mistake? What can so in the worst case, the spindle has a wrong value in the tool and it drives against a chuck or a fixture, and kind of that's a big loud bang that none of the shop owners want to hear. Yeah, and then you got at least the machine is broken and the tool is broken, and maybe even the parts. So even the fixtures, which are also very expensive, high accuracy devices that need to stay in order. So that would be one step to start using the presetter and eliminate the human error from this typing of these tool values. Yeah, for sure. Then next steps, what do you say?
Well, if you have a presetter, then the next step might be, for example, investment on automation, like our FPC or robot cell with the control software properties, where you can handle these geometrical values with comma and 4 digits after that automatically, so you reduce the typing errors to the minimum. And then step after that would then be automating the whole tool transfer with centralized tool storage system.
Yeah. What kind of companies, because we do quite many tool handling systems and cases. And what kind of companies typically go after these solutions?
Well, the centralized tool storage are worthy when you have some more machines connected in the same automation system. So it's
like approximately how many?
Let's say four or five starting with. Yeah. And then, companies that require a lot of tools are either subcontractors with loads and loads of different parts they need to make.
Oh, great. So there's a variance.
Yeah. Or companies that manufacture different or difficult materials.
Yeah. Such as
aviation technology, for example.
Yeah, that's a good example. I've understood that tool management can be also arranged without the automation, and I'm meaning here the scheduling part. Would you guys elaborate that a little bit also around the workshop operation topic?
Sure.
Seppo knows that very well.
Yes. Our control software, the MMS, can be utilized also without automation hardware in one type of an MES solution, calculating the work queues in advance for manually operated machines. And also these manually operated machines can be connected to the control system with the tool data management software modules, which means that for standalone machines, the control software is able to firstly calculate which tools are needed in advance.
Sure.
And if wanted, also to be used for transferring the tool data into the machine tool control.
Yeah, but that sounds like a lot.
Well, that is a lot. You get loads of the benefits of the automation system without the investment on the automation hardware. Yeah. And this, of course, can be also put into use in such a processes that cannot be easily automated.
All right, it's time to wrap up this episode of tool management. I at least learned a lot here, and it sounds that there's a lot to gain with good tool management, and there are also some quite easy wins that you can have here, like Seppo mentioned before. Now, if you would like to learn more about our resources, you can access our YouTube, our other podcasts, and our blog at fastems.com/blog. At this point, I thank you for listening, and also thank our guests today, Teemu-Pekka and Seppo.
Thank you.
My name is Mikko Tuomala. Thank you.